everyone, I am Gumban from BSECE-3A, and today I'm going to demonstrate the functionality of a liquid crystal display or our LCD using our microcontroller board or our Arduino Uno R3 board. For this task, I'm going to implement the scroll up and scroll down function. So without further ado, let's get right into the video. Materials needed. We have our 10K ohm potentiometer, 10K ohm resistors, 330 ohm resistors, tap switches, our jumper connecting wires, our male pin headers, our 16x2 LCD, our Arduino Uno R3 with cable connector, our breadboard, soldering lead, and soldering iron. Schematic diagram and wiring connections. Wiring connections. Schematic diagram. Soldering. First, attach the male pin headers to the LCD. Next, solder all pins in the LCD. Always remember to make sure not to short the connections. Breadboarding. For our breadboarding, first we pin the LCD to the breadboard. After that, we connect the 330 ohm resistor to the backlight cathode and to the ground. Also, we connect the backlight anode to our positive 5 volts DC. Next, we pin the potentiometer to the breadboard. And now we are adding jumper wires to connect the pin 1 of the potentiometer to the positive 5 volts DC. Next is to connect pin 3 of the potentiometer to the ground. Also, add a jumper wire to connect pin 2 of the potentiometer to the VO of the LCD. Then pin the tap switches to the breadboard. Connect 10K ohm resistor from the one end of the switch to the ground. Connect the other end of the switch to the positive 5 volts DC. Then add jumper wires to the gap of the breadboard. Now we add jumper wires to the ground connection. Now we are connecting pin VSS to the ground. Also connect pin VDD to the positive 5 volts DC. Now we connect the center pin of the potentiometer to the VO. Now we are connecting pin RW to ground. And add connecting wires to the other pins of the LC. Add connecting wires to the ground and the positive 5 volts DC for our Arduino board. Add connecting wires to the task switches as well. Connect wires according to the standard pin connection. We have the VSS for the ground, VDD for the positive 5 volts DC, VE via 1K ohm to ground, but in our case we use our potentiometer, so we connect the center pin of the potentiometer to the VE, RS to pin number 12, RW to ground, we have T to pin number 11, D0 to D3 is not connected, D4 to pin 5, we have D5 to pin 4, D6 to pin 3, D7 to pin 2, and backlight anode to positive 5 volts DC, backlight cathode via 330 ohm to ground. Make sure that all connections are correct. So for our coding, first we declare our functions. Here we have our pin assignment and declaration, where the pin 12 is for RS, our pin 11 is for E, our pin 5 is for D4, our pin 4 is for D5, our pin 3 is for D6, and pin 2 is for D7 respectively. So here we have our variable count pages, which corresponds to our page counter. And we also declare our variables up current, up last, down underscore last, and down underscore current, which we initiate it in a low state. Also, we declare our variables for our task switches. We have the up underscore button for our pin number 8, down underscore button connected to our pin number 9. So in this part, we have here the Greek symbols which we customize for our problem. So first is we have the phi symbol for our power, the nu symbol for our potential difference or our voltage, the eta symbol for charge, the omega symbol in the Greek letters for work, our degree 6, our home indicator, our arrow down, and the tau for our time. After generating the codes for our customized characters through our LD generator, and now we already set the number assignment for our created characters. First is we have 1 for our power, 2 for our voltage, 3 for our charge, 4 for our work, 5 for our 6 degree, 6 is for our home, 7 for our arrow down indicator, 8 is for our time. After that, we have here the debouncing functions for our conditions in order to perform the scrolling options and also to initiate the conditions given in our guidelines. After that, we have here the conditions for our page up. So if we're going to scroll up, here we have the if else condition. If count pages is greater than 1, count pages or the pages will be deducted by 1 or it will be subtracted by 1, and this page can be scrolled up. If otherwise, page 1 will be displayed and will not perform scroll up. Conditions for page down. If count pages is less than 36, count pages will be added a plus 1 and page can be scrolled down. If otherwise, from the last line, it will go back to page 1. The number 36 here corresponds to the number of cases or number of lines that we have in our problem or in our code. So here we can see that we have here the pages or our lines. For the line 1, for the first line, the second line, and our arrow symbols or indicators displayed for our LCD. We have here a total of 36 lines for this activity. After compiling, we're going to upload it to our Arduino board. Now it's already done uploading. Demonstration of functionality. First, we connect our Arduino board to our power source. Twist the potentiometer knob to adjust the light intensity of display. Now that we have our desired intensity of our display, we are going to demonstrate the first function, the scroll down. Problem solving by PI Gumban. Compute the work and the average power required to transfer 96 kilocoulombs of charge in 1 hour through a potential rise of 50 volts. Solution. Let omega equals to work, eta equals to charge, phi equals to power, nu equals to voltage, and tau equals to time. Given charge equals to 96 kilocoulombs or equals to 96,000 coulombs. We have the voltage equals to 50 volts and t or our time equals to 1 hour or 3,600 seconds. Formulas needed. Work equals to charge times the potential difference and power equals to work over time. Solve for work. Now we are substituting the values of our given B. Solve for power. By substituting the values, we get, and our final answer equals to work equals to 4.8 megajoules and power equals to 1.3 kilowatts. Condition 1. When last line is scrolled down, it will be back to the first line. Condition 2. If the first line is displayed and scrolled up is pressed, it will not respond. Function 2. The scroll up. From the last line, we are scrolling up to the first line. We reach the first line. So this concludes the demonstration of the functionality.